In this class, we're going to look at the method of evaluating the limit of a function. Okay? We have direct substitution method. Direct substitution method. Let's start with that. Direct substitution. Okay? If you want to evaluate the limit of a function using direct substitution method, all you have to do is that just substitute the limiting value. You get what I'm trying to say? Just substitute the limiting value into the function that you are given. Okay, you are going to arrive at an answer. Okay, so let's look at question on direct substitution method. Let's say you are asked to evaluate the limit of this of the following function. Evaluate the limit of the following function: lim x squared plus 1 as x tends to 1. Okay, now the second one, we have limit x to the power of 2 minus x minus 1 all over 2x to the power of 3 plus 1 as x tends to 5. Okay, then the third question, limit 4x plus 1 as x tends to 0. Okay, now we are asked to take the limit of the following function using direct substitution method. Now all you have to do here is that just substitute the limiting value that you have into the function that you are taking the limit. Okay, so for this I'm going to replace x as 1 here. So I'm going to have, instead of x, I'm going to have 1 to the power of 2 plus 1. You understand? That will be what? 2. Okay, now for this I'm going to replace x as 5. So I'm going to have 5 squared minus 5 minus 1 all over 2 multiplied by 5 to the power of 3 plus 1. Okay, 5 squared is what? Is 25. 25 minus 5 is 20. 20 minus 1 is 19. So I'm going to have 19. Now we have 5 to the power of 3. 5 times 5, 25. 25 times 5, that is 125. 125 times 2, that is 250. Okay, 250 plus 1, that is 251. 251. So using direct substitution, that is the value that you're going to have. 19 all over 251. Now for the third one, for the third function, we have just to replace x as 0. So I'm going to have 4 multiplied by 0 plus 1. Okay, 4 times 0 is what? 0. Okay, and we have plus 1, so the answer to this is plus 1. So now I want to attempt this question. I'm coming. I want to attempt this question. Take the limit of this. What are you going to have? I want to attempt this question. Limit x to the power of 2 minus x minus 1 all over 2x to the power of 3 plus 1 as x tends to minus 5. Now I want to attempt this question. Take the limit of this function as x tends to minus 5. What are you going to have as your final answer? Okay, all you have to do is that just replace x as minus 5 in this function. Okay, so the answer that you get, if you get the answer, you're correct. I mean, if you get the answer to that question should be negative 29 all over 249. You understand? If you substitute negative 5 as the value of x in this function, you're going to have negative 29 all over negative 249. Okay, this is what we call direct substitution method. Now there are some functions that if you take their limit using direct substitution method, you are not going to arrive at an answer. You understand? So such function can be you can evaluate the limit of such function using another method. You understand? So we are going to look at some of the function here. Okay, just pay attention. Let's consider the question that we have on the board. You are asked to take the limit of the following function. Now this method that we are going to use here is what we call simplification method. You understand? All you have to do first is just simplify the function that you are given before you substitute the limiting value. You get what I'm trying to say? Okay. Now, for the first question, you can see that you can make use of difference of 2 squared for the numerator, you understand? The numerator of this function can be written as, listen, the numerator of this function can be written as 1 squared minus x squared all over 1 minus x, you understand? So, using difference of 2 squared, you're going to have 1 plus x multiplied by 1 minus x. This all over 1 minus x, okay? So, this will cancel this, so you're left with 1 plus x. Now, honestly, if you substitute the value of x as 1, you're going to have 0, you understand? So, in this case, you make use of simplification method. So, if you substitute the value of x as 1, the value will be 0 over 0, and that is indeterminate, you understand? So, in that case, that is why we proceed to simplify the function before we substitute the value of x as 1. You get it? So, now, having simplified the function, we have 1 plus x. Now, we can now substitute the value of x as 1. So, I'm going to have 1 plus 1, which is what? 2. Okay? For the next function, we have limit x all over root of 4 plus x minus 2 as x tends to 0. Now, to take the limit of this function, we have to rationalize, you understand? I'm very sure you have heard of conjugate before, okay? We have to rationalize. So, what I mean by rationalization is this. You can see that this is the function that we are given, x all over root of 4 plus x minus 2. Now, if I want to rationalize this function, I'm going to multiply the numerator and the denominator by the conjugate of the denominator. You understand? This one, you should have been familiar with this. You have to multiply both the numerator and the denominator by the conjugate. So, the conjugate of the denominator is root 4 plus x plus 2. So, I'm going to multiply both the numerator by and the denominator by root 4 plus x plus 2 all over root 4 plus x plus 2. So, for this, I'm going to have x root 4 plus x plus 2 all over. Now, root 4 plus x multiply with 4 plus x. That will be what? 4 plus x. Okay? Now, this multiply this, you're going to have plus 2 root 4 plus x. And this multiply this, you're going to have minus 2 root 4 plus x. And minus 2 multiplied by plus 2. That means you're going to have negative 4. Okay? Now, you know that, please pay attention. Do you even know what I'm doing at all? I just go, I show you this next step because I want you to understand it, okay? I'm very sure you will have heard of conjugate before. I take the conjugate of the denominator. The conjugate of the denominator is what? Root 4 plus x minus 2. So, root x plus 4 plus 2. So, I multiply both the numerator and the denominator by the conjugate of the denominator of the fraction, okay? Now, having done that, if you multiply this by this, you're going to have this. This times this, you're going to have, this times this, you're going to have this. This times this, you're going to have this. Okay, plus 2 times this, you're going to have this. The minus 2 times root of 4 plus x, you're going to have this. The minus 2 times plus 2, you're going to have negative 4. Okay. Now, having gotten to this point, you can just this can eliminate this because we have positive 4, negative 4, and this can eliminate this as well. So, the final answer, the conjugate, you're going to have x root 4 plus x plus 2 all over. Now, we don't forget that we are having x here. We are only left with x. This plus 4 cancel this negative 4. This plus cancel this. You understand? So I'm going to have this over x. Now, if you are solving this in the exam, you didn't have to show all this long step, okay? It is because I'm teaching you. That's why I want you to understand what I did before I put the function x. So I'm going to have, here we're going to have x root 4 plus x plus 2 all over x. Now, don't forget as well that this x can cancel this x. So we are left with what? We are left with root x root 4 plus x plus 2. Now, please pay attention. When x is 0, what are you going to have? You're going to have root 4 plus 0 plus 2. Now, root of 4 plus 0, that is what? Root of 4. Square root of 4 is what? Is 2. You understand? So I'm going to have 2 plus 2. And 2 plus 2 is what? Is 4. So the limit of this function as x tends to 0 is 4. Do you understand? Okay, now let us look at the third question. We have limit x to the power of 3 plus 4x all over x squared minus 2x as x tends to 0. For the third question, all you have to do is that just factorize. You understand? You have to factorize x, both the numerator and the denominator. So for this, I'm going to have x to the power of 3 plus 4. Okay, x to the power of 2 now. X to the power of 2 plus 4. All over now x minus 2. What I did was that I just factorized x. You understand? I factor out x in both the numerator and the denominator. Now, having factorized x, this can cancel this. So I'm left with what? X squared plus 4 and all over x minus 2. Now, please. So we have x squared plus 4 all over x minus 2. Okay, I think the question is ambiguous. Okay, let's check. I think something is wrong. Because do you know the reason why I said that? The reason is because if you take the difference of 2 squared here, you're not going to have, you're still going to have indeterminate, you understand? So I think, let's change this to negative, you understand? So I'm going to have negative here. Let's change this as well to negative. So this will become negative as well. Now, we can take the difference of 2 squared. You understand? Because x squared minus 4 can be written as x to the power of 2 minus 2 to the power of 2. And the difference of 2 squared will be x minus 2 and then x plus 2. You understand? So for this, I'm going to have x minus 2 multiplied by x plus 2 all over x minus 2. You understand? Now, don't forget that this x minus 2, we can eliminate this. So we are left with what? X plus 2. Now, when x is 0, you understand? I'm going to have 0 plus 2. 0 plus 2 is what? 2. You understand? So 0 plus 2 is equivalent to 2. So the limit of the function x to the power of 3 minus 4x all over x squared minus 2x is, as x tends to 0, is the limit is 2. You understand? Okay, so I'm very sure you understood how to take the limit of a function using simplification method now. It is also possible to use another method to take the limit of a function, like especially when you are evaluating the limit of a function as the limiting value tends to infinity. You understand? So we have done that in our previous class though, but we didn't delve more into complex question. But in this class, we're going to look at it. Okay, the limit of a function to infinity. How do you do that? Let's consider the question on the board. We are asked to take the limit of 2x squared plus x minus 1 all over 3x squared minus x plus 1 as x tends to infinity. Now, because infinity is not an actual value, you understand? It doesn't have an actual value, so we need to manipulate this function. You understand? Are you getting what I'm trying to say? We need to manipulate the function by dividing both the numerator and the denominator by the highest power of the variable of the denominator. Listen to the explanation again. It's simple. Now, you can see in that question, x tends to infinity. Infinity is not an actual value, you understand? So we have to manipulate the function. How do we do that? By dividing both the numerator and the denominator by the highest power of the variable at the denominator. You can see? Now, the highest power of x at the denominator is what? Is x squared, you understand? So the first step is that I'm going to divide both the numerator and the denominator of this function by x squared, you understand? Now, if I have x cubed, I'm going to divide both the numerator and the denominator by x cubed, you understand? So now, because I'm having the highest power of x at the denominator is what? X squared. So I'm going to divide both the numerator and the denominator by x squared. So the function becomes like this: 2x squared all over x squared, you understand? 2x squared all over x squared plus x all over x squared minus 1 all over x squared. Now put the division sign. This 3x squared all over x squared minus x all over x squared, all over x squared plus 1 all over x squared. Okay, now for this we're going to have 2, you understand, plus 1 over x plus, okay, minus 1 over x squared, 1 over x squared. Okay, this all over 3 minus 1 all over x squared plus 1 all over x squared. Now, the final answer to this question will be 2 all over 3. I'm going to explain. Just pay attention. In our previous class, we learned that if you take the limit of a function of this kind, 1, 2, 3, 4, if you take the limit of a function of this kind as x tends to infinity, you are going to have 0. You understand what I'm saying? So, if you missed the class, kindly check the link. Check the link in the description of this video to watch the class. Okay, so the final answer to this kind of question, is 2 over 3, and the reason is because all this will be 0, this will be 0, this will be 0, and this will be 0. Okay, so now for the next question we have limit 4x squared minus x all over 2x cubed minus 5 as x tends to infinity. We are still going to go the same way. First step is divide both the numerator and the denominator of this function by the highest power of the variable. The variable here is x, you understand? So I'm going to divide both the numerator and the denominator by the highest power of x at the denominator. The highest power of x at the denominator is what? S cubed, you understand? So for this I'm going to have, please pay attention, I'm going to have 4x squared all over s cubed minus x all over s cubed, this 2x cubed all over s cubed minus 5 all over s cubed, you understand? So for this we're going to have 4 over x minus x all over s squared, this all over 2 minus 5 all over s cubed. The final answer will be 0. Do you know the reason? Because the numerator here will be 0, 4 over x will be 0, x over s cubed also will be 0, you understand? 2, okay, this is what we're going to have, 0 minus 0 all over 2 minus 0. This is what? 0 over 2. You can see now. I hope you understood what I did. Listen to me, listen to the explanation again. If you are taking the limit of a function to infinity, you understand? Infinity is not an actual value, so we have to manipulate the function. And another method of dealing with question on limit is that you divide the function by the highest power of x at the denominator, you understand? So, and that's what I did for the first and the second question. So having done that, I discovered that infinity is not an actual value, and in our previous class that we have learned that the limit of a function like this as x tends to infinity will give us 0. So this will give me 0, this will give me 0, this will give me 2 because it doesn't have x, and this will give me 0 as well. So I have 0 over 2. What is 0 over 2? It's not an actual value. So the limit of that function as x tends to infinity will be 0. You get what I'm trying to say? Now, if you look at this kind of function, please pay attention. If you look at this kind of function, it's not that their limit does not exist. You understand? Most time, it's not that their limit does not exist. It's just because maybe the method that we use is not suited. It's not suitable for the function. You get what I'm trying to say? And that's why I explain many. We talk about many methods. You understand? I think we've talked about direct substitution method, simplification. Now we are talking about manipulation. This one is just like a method of manipulation. You understand? You manipulate the function by dividing both the numerator and the denominator by the highest power of x. Now, if that method does not work, there is another method known as L'Hospital rule. You understand? We're going to talk about L'Hospital rule. That's the next method that we're going to talk about. L'Hospital rule. Okay, to take the limit of a function using L'Hospital rule, the function must be differentiable. You understand? That is, you must be able to differentiate the function, the numerator of the function and the denominator of the function easily. You understand? So let's consider the question that we have on the board. We have limit x to the power of 4 minus x to the power of 3 minus 2x plus 1 all over x to the power of 2 plus 4x minus 5 as x tends to infinity. as x tends to infinity. Oh, sorry. And you can put it, but let's use as x tends to 1. You know that I want to show you that the reason why I don't want to put infinity in that question is that, if you want to make use of infinity, you have to manipulate the function, because infinity is not an actual value. You get what I'm trying to say? So let us use as x tends to 1. Now, honestly, if you substitute the value of x as 1 into this function, please pay attention. You're going to have 1 minus 1, 0. Minus 2 plus 1, that is what? Minus 1, right? 1 plus 4, that is what? 5. 5 minus 5 is 0. You're going to have minus 1 all over 0. That will be what? Maybe we should try it. Let's try it. Direct substitution method now. Before we make use of L'Hospital rule, we want to try maybe. I told you that there are some functions that they cannot be, you cannot evaluate their limits using direct substitution method. A typical example is this kind. Okay. Now, if you substitute the value of x as 1, you are going to have 1 to the power of 4, which is 1. Okay. 1 minus 1 minus 2 plus 1 all over 1 plus 4 minus 5. And this will be what? 0 minus, this is minus 1 all over 0. You can see now. So now, in that case, that means that we are going to make use of another method. So if you confront if you are trying to evaluate the limit of a function in exam, just use the method that is suitable for that function. You understand? The method suitable for that function, that's my advice, okay? Let's also make use of L'Hospital rule. According to L'Hospital rule, if you take the limit of a function and the limit is not, maybe is indeterminate, according to L'Hospital rule, you have to differentiate the numerator and the denominator of the function individually. You understand? So let us take the derivative of the numerator. For this, if you take the derivative of x to the power of 4, you are going to have 4x to the power of 3 minus 3x to the power of 2 minus 2 all over 2x plus 4. You understand? Now, let us substitute the value of x as 1. For this, you are going to have 1 to the power of 3 minus 3, 1 to the power of 2 minus 2 all over 2 multiplied by 1 plus 4. For this, you are going to have 4 minus 3 plus 2. Okay, 4 minus 3 minus 2 all over 2 plus 4. That will be what? Negative 1 all over 6. Okay? So you can see now, L'Hospital rule is suitable for this kind of function. You understand? The final answer is negative 1. Negative 1 all over 6. Okay? Now, let us look at another question. Maybe you should try this. Limit sine x minus cos x all over x to the power of 2 as x tends to 0. I want to attempt this, okay? Now, I want to pause this video, attempt that question, then when you are done, play the video to check maybe your answer is correct, okay? Now, let us solve it together. If you substitute the value of x as 0, you are going to have sin 0 will give us 0, and cos 0 will give us 1. So we are going to have negative 1 all over 0. So in that case, we have to use L'Hospital rule, you understand? So this kind of function, you can easily differentiate the numerator and the denominator. And that's what I'm going to do now. Okay, this is what I mean. If you substitute the value of x as 0, you're going to have sine 0 minus cos 0 all over 0 squared. So for this, you're going to have sine 0 will give us 0, cos 0 will give us 1. So 0 minus 1 over 0, that is minus 1 over 0. So for this kind of function, you can easily differentiate the numerator and the denominator using the L'Hospital rule, and then you carry out the substitution. Before you substitute the value of x as 0. So for this, differentiate sine x, you're going to get cos x. Cos x. If you differentiate negative cos x, you're going to get plus sine x. All over, if you differentiate x squared, you're going to have 2x. Do you understand what I did? Let me explain again. The reason why I differentiate the numerator and the denominator is because when I substitute the value of x as 0, I discover that I'm going to arrive at negative 1 all over 0. So I have to use L'Hospital rule. And according to L'Hospital rule, if you come across a function that direct substitution does not work, you have to differentiate the function. Then you now substitute the value of x, the limiting value again, into that function, okay? So when I differentiate sin x, I get cos x. If you differentiate cos x, you're going to get minus sin x. Now, because we have a minus there before, that will be what? Minus sin x. Minus sin x will be what? Plus sin x. You get what I'm trying to say? So that's how I got plus sin x there. Now, let us substitute again. This is the first derivative, you understand? The first derivative of this function is this. So let us substitute. If you substitute the value of x as 0, you're going to get cos x and cos 0 plus sin 0 all over 2 multiplied 0. We are still not going to arrive at a value, you understand what I'm saying? So we have to differentiate this function again, okay? Listen to the explanation again. See, when I first substitute the value of x as 0, I didn't arrive at an answer. So I differentiate this function, I got this. Then when I substitute the value of x as 0 again, I have cos 0 minus sin 0 all over 2 multiplied 0. Cos 0 will give me 1. 1 plus sin 0. Sin 0 will give us what? 0. So I'm going to have 1 all over 0. You can see now. So we still have to differentiate this function again, okay? We still have to differentiate it again. So if you differentiate cos x, okay? If you differentiate cos x, you're going to have what? You're going to have sin x. And if you differentiate sin x, you're going to get minus cos x all over. If you differentiate 2x, you're going to have 2, okay? So the derivative of this function is this, and the derivative of this function is this. Now, let us substitute. I'm going to have sin 0 minus cos 0 all over 2. So for this, sin 0 will give us what? 0. I'm going to have 0 minus 1 all over 2, which is what? Minus 1 all over 2, which is that's the answer to that question, okay? If you have any question regarding L'Hospital rule, let me know in the comment section. Do you understand? Okay, so that is the answer to that question. Now, we have talked about direct substitution method. We have talked about simplification and rationalization method. We've talked about another method known as manipulation method. Then we talk about L'Hospital rule. Now, let us look at questions on all these methods that we have talked about. Okay? Let's consider the question that we have on the board. We are asked to evaluate the limit of the following function. Okay? Let's start with the first question. Now, I want to understand something. If you take the limit of a function using a specific method, and that method does not work, use another method, okay? So, let us start with the first question. We have limit x to the power of 6 plus 4x squared minus x as x tends to 2. Let us use direct substitution method. For the first question, we have question, that is A. If you want to use direct substitution method, you're going to have 2 to the power of 6 plus 4 multiplied by 2 to the power of 2 minus 2. For this, you're going to have 64 plus 4 multiplied by 4 minus 2. 64 plus 16 minus 2. Now, 64 plus 16, that is what? 80, you understand? 80 minus 2 is what? 80 minus 2 is 78, okay? So this will be 78. Now, the first question is 78. Now, for the second question, we have to limit x to the power of 2 minus 9 all over x squared plus 3 as x tends to 3. That is question 2. Now, if you want to use direct substitution method, you're going to have 3 raised to the power of 2 minus 9 all over 3 raised to the power of 2 plus 3. Okay, for this I'm going to have 9 minus 9 all over 9 plus 3, which is what? 0 all over 12. Okay, you can see that direct substitution method did not, it doesn't work. So what are we going to do for this kind of function? Well, you can make use of L'Hospital rule and you can also use manipulating method, you understand, whereby you divide both the numerator and the denominator by the highest power of x at the denominator. You get what I'm trying to say? So anyone that works. So let us try L'Hospital rule. Let us try L'Hospital rule. According to L'Hospital rule, we have to differentiate the numerator and the denominator of this function individually. So I'm going to differentiate 2x and x squared. I'm going to have 2x. If you differentiate negative 9, you're going to have 0. So I'm going to have 2x all over. Now, if you differentiate x squared, I'm going to have 2x as well. You understand? And if you differentiate plus 3, you're going to have 0. Minus 0 plus 0. Okay? That will be what? 2x all over 2x, which is what? 1. Do you understand? Let's proceed to question C. Now for question C, we have x squared minus 2x all over x as x equals to 0. Now, if you use direct substitution method, it's not going to work. The reason is because this will be 0 all over 0. You get what I'm trying to say? Now, we have to make use of L'Hospital rule, which means we are going to differentiate both the numerator and the denominator, okay? So let us differentiate the numerator. You're going to have 2x minus 2 all over. If you differentiate the denominator, you're going to have 1 all over 1, which is what? 2x minus 2. Now, when x is 0, at x equals to 0, I'm going to have 2 multiplied by 0 minus 2, which is what? Minus 2. Okay, now let us use the manipulating method. If you want to use the manipulating method, you have to divide both the numerator and the denominator by the highest power of x at the denominator. Now, because we are only having x at the denominator, I'm going to have x squared. Please pay attention. I'm going to have x squared all over x. X squared all over x minus 2x all over x. Now, if you take the division of this, you're going to have x squared divided by x, you're going to have x minus 2. You can see that we still arrive at the, if you substitute the value of x as 0, you're going to have 0 minus 2. So this is what? Minus 2. So if you use the manipulating method or you use the L'Hospital rule, you are still going to arrive at negative 2. You get what I'm trying to say? So for this, you see, if you come across this kind of question in exam, just use the method that is more suitable for you. Okay? So I'm very sure you can test. I want to check this question number 4. Tell me the method that is more suitable. I'm very sure you are aware that if you substitute the value of h as 0, you're going to have negative 9 all over 0. You understand? So I'm very sure you are aware that that method cannot work. You're not going to have a significant answer. So for this kind of method, you can use L'Hospital rule and you can use the manipulating method that I taught you. So the third question is negative 2. That's the answer to the third question. I want to pause the video, then attempt this question. Then when you are done, check maybe your answer is correct. Now, dealing with this question, the first step, if you want to use L'Hospital rule, let us first expand. You understand? So if you want to expand, I'm going to have 3 plus h squared can be written as 3 plus h multiplied by 3 plus h. You understand? Then you can put this negative 9 minus 9. This all over h. So for this, I'm going to have 3 times 3 is 9. 9 plus 6h plus h squared minus 9 all over h. Okay, you can still simplify further. So for this, I'm going to have, now this negative 9 here, we eliminate the positive 9. So for this, I'm going to have 6h plus h squared all over h. Now, having gotten to this point, I'm very sure you are aware, if you substitute the value of h, okay, if you substitute the value of h as 0, you're going to discover that you're going to have 0 over 0, which is indeterminate. So you have to use L'Hospital rule. Like I said, using L'Hospital rule, we have to differentiate the numerator and the denominator individually. If you differentiate 6h, you're going to have 6. So for this, I'm going to have 6. If you differentiate plus h squared, you're going to have plus 2h. So I'm going to have plus 2h all over, if you differentiate h, you're going to have 1. This all over 1. Now, let us substitute now. If you substitute the value of h as 0, you're going to have 6 plus, now 2 times 0 will give us, okay, well, let's do it. All over 1. 2 times 0 is 0. Then 6 over 1 will be 6. Hence, the limit of the function at h equals to 0 will give us, the final answer will be 6, okay? Now, when we use L hospital rule, what do we get? We got 6 as our final answer. Now, I want us to use the manipulating method. You understand? Now, don't forget that it is at this point that we make use of L hospital rule. Please listen. This is the function. When this function is simplified, this is what we arrive at. You understand? Now, when we use L hospital rule here, we got the value of the limit. We get the limit of the function as what? As 6. Now, let me erase this. From this point, let us use the manipulating method. What are you going to do? You divide the numerator and the denominator by h, right? Yes. So for this, we are going to have 6h divided by h. 6h divided by h, that will be what? 6, right? And then h squared divided by h, that will be what? Plus h. Then h divided by h, that will be what? 1. So for this, we're going to have 6 plus. Now, when h is 0, we're going to have 6 plus 0 over 1. 6 plus 0 over 1 is what? Is 6. So you can see that whether L hospital or the manipulating method, you're still going to arrive at the same answer. So if you come across any function in the exam and you discover that direct substitution will not work, it's better you use number 1, L hospital rule, or try and manipulating method. And if those two methods does not work, then you can make use of if the function consists of a square root, you can rationalize. And if it doesn't, you can simplify it. Okay, so those are the methods that you need to know. Now, because if you come across this kind of question in the exam, in the objective, I will advise you to just use the method that is that you know very well. You understand? The method that you are very familiar with, because nobody will ask you to show your solution. Okay, so let me just give you an assignment. You can attempt this. Attempt this question. I want to attempt this. X squared plus x plus 6 all over x squared minus 2x plus 1 at x tends to 1. I want to take the limit of this function as x tends to 1. So,
to learn more on limit of a function, kindly check the description of this video. You're going to see a link there. Click on that link and watch the class, okay? So and before you go, don't forget to hit the like button, okay, and subscribe to the channel, and make sure that you share this video to your friends and your classmates. See you in the next class.